Today's lesson is solving equations that have variables on both sides. In solving equations, something you guys do a lot, and I think you're probably very good at it. So that's a good thing. When you've got variables on both sides, you want to get all the variables on one side of the equation, either left or right, and all the things without variables, all the constant terms on the opposite side. Solve your equation as you normally would, check your solution, make sure you're solving for a positive variable, so on and so forth. So it doesn't matter where you decide to bring all the variables, it's your choice left or right. I'm going to bring the variables to the right because that's where I have more of them. Negative 8x on the left, positive 4x on the right. My right-hand side is the positive value, so that's got more of the variables. So I'm going to add 8x to both sides. When I do that, I get 7 equals 12x minus 17. And now if variables went to the right, without the variables, my constant terms go to the left. That's why I'm going to add 17 to both sides. And then what happens here is you get 24 equals 12x, divide both sides by 12, and 2 is equal to x. Again, I can't stress enough that we've been getting a lot of integer answers, and that's not always the case. If you end up getting a fraction answer from time to time, a rational number, it's all good. Okay, second one, you do have the distributive property, so you need to make sure that you do that first. So on the right-hand side, I'm going to distribute, and I'm going to get 6x minus 8. And on the left-hand side, I bring down what I didn't use, 5x minus 2 equals. In this case, I'm actually going to bring the variables to the left, even though normally I would go to the right because there's more there, but that's okay. I'm going to subtract 6x from both sides, and I'm going to get negative 1x minus 2 equals negative 8. The letters go left. The numbers that don't have the letters go to the right. I'm going to add positive 2 to both sides and get negative 1x equals negative 6. Again, you can never solve for a negative variable. It must always be positive. Divide both sides by negative 1, and x equals positive 6. Okay, I wonder if something is not right here. Hold on. 5x minus 2 equals 6x minus... Oh, no, that's right. My notes happen to be wrong on this one. Okay, so that's good. Go to the next one. Again, choose a side for the variables to go on. I'm going to choose the right-hand side. So I'm going to add 3 to both sides. Really, it's add 3x. And then I'm going to get 9 equals 17 plus 1x. If letters went to the right, without letters go to the left. Subtract 17 on both sides. And negative 8 equals x. All right, hold on 1 second. All right, so then we get to number 4. We've got a fraction on this one. Now, with this particular fraction, as I look at it, I do see that both 16 and 60, the numbers in the parentheses, happen to be divisible by 4. The fact that they are divisible by 4, I think what I'm going to do, instead of clearing the fraction, I'm just going to distribute through. Okay, because that's going to make the fraction go away anyway. So what happens here is 9x plus 5 stays as is, but a fourth of 16, which means 16 divided by 4, that's just 4x. And then minus a fourth of 60, or 60 divided by 4, is just going to be 15. So I didn't have to worry about multiplying both sides by 4. I totally could have done that. But the fact that 1/4 divides in evenly, or distributes evenly into the parentheses, I thought that would be easier. I'm going to bring all my x's to the left by subtracting 4x. 5x plus 5 equals negative 15. If x's go left, numbers without x's go right. Subtract 5 from both sides and get 5x is negative 20. Divide both sides by 5 and x is negative 4. Okay, here's the last one. Alright, so the last one is dealing with 2/3. So actually, I can also take 2/3 of both 6 and 15 because 3 divides evenly into 6 and into 15. So this one I'm going to go for the distributive property also. I think it'd be much bigger numbers if I don't. So again, always look to see if you have a fraction, if that fraction divides in evenly to whatever you need for it to divide evenly into, then you actually do that. If it doesn't, then it's when you maybe want to multiply both sides of the equation by the denominator. So here's what's going to happen here. I am basically doing math again. I'm going to say, well, what is 6 divided by 3, which is 2? And I'm going to multiply that by this numerator 2 and the x. And what happens is 6 divided by 3 is 2. 2 times 2x, excuse me, is 4x. Plus to plus. I'm going to do it again. 15 divided by 3 is 5. 5 times 2 is 10. So I'm actually taking 2/3 of 6 and 2/3 of 15. So divided in nice and evenly. On the left-hand side, I'm good with 8x minus 6. I'm going to bring all the letters to the left by subtracting 4x. 4x minus 6 is 10. I'm going to bring all the numbers to the right by adding 6. 4x equals 16. And now I'm going to divide both sides by 4. And x equals 4. Okay? So again, if you have the chance to actually do a fraction that divided evenly into whatever numbers you're working with, I would do that first. If not, that's when I would clear the fractions that we had done in days past. Okay? So good luck on your homework.